A chord is a segment that connects any 2 points on the circle. So if I were to put that in a diagram, I can choose any 2 points along the circle, and if I connect them with the segment, that segment is called a chord. Okay, so it's going to be a segment with endpoints on the circle. If we were to compare this to a radius does not have its endpoints on the circle. It has its endpoint on the center, one endpoint in the center, and one endpoint on the circle. Okay? As opposed to the chord, both of their endpoints are along the circle. We talked about diameter, recently in another lesson, and a diameter is actually a type of chord. The diameter, if you looked at it, has endpoints on the circle. So a diameter is actually the longest chord within the circle. So yes, diameter is a type of chord. So we're going to look at 4 properties or 4 different types of problems that we can use chords in. So there are 4 properties that we will look at. First one, if 2 chords are congruent, then their minor arcs are also congruent. So their lengths are going to be congruent, their degree measures are going to be congruent, as long as the chords, these 2 chords are congruent. The arcs that they form will be congruent to each other. Second property with chords, if a diameter or a radius is perpendicular to the chord, then it bisects the chord and its arc. So you can see we have our diameter, or you can think of it as our radius here, and it is perpendicular to this chord. Okay. If it's perpendicular, just like the property states, we are getting bisected, meaning we have 2 equal parts in the chord, and our arcs are also split in half. Third property, if 2 chords are blank from the center, so if the 2 chords are equidistant, meaning they are the same distance away from the chord, then they are congruent. So as indicated by this line here, the 2 chords A, B, and BC are the same distance away from the center, so they will be equal in length. And then finally, to find the radius using these chords, we can see that we have a perpendicular intersection here. We can actually use Pythagorean theorem in order to find a missing radius. And we'll take a look at all these examples in class. You can go ahead and try to look at them and see if you can get some of these, and we will go over each of these examples based on the properties in our lesson.